If you're experiencing poor fuel economy, or your car just isn't running right, most likely your engine's in need of a tune-up. Hi, I'm Scott Cusey, and I'll be your host as we demonstrate the basic steps necessary to do your own engine tune-up. It's really not that difficult, and can usually be completed in a single afternoon. This tape is designed to give you a basic understanding of the steps required during a tune-up, what specialty tools are necessary to do the job right and how to use them. And it also contains some helpful tips and troubleshooting procedures to help you determine when it's time to replace certain components. Now, of course, the level of complexity involved with each task will vary from vehicle to vehicle, but most of the procedures I'll demonstrate are easily accomplished by even the first-time do-it-yourselfer. Before we get started with the tune-up, I'd like to share a few safety tips to keep in mind when working around vehicles. First, never wear loose clothing or jewelry. You could get caught in something and cause an injury. Never smoke when working on a vehicle, because there are several highly flammable vapors that could start a fire or even trigger an explosion. And be sure to have proper ventilation if you're running the engine in an enclosed area. To prevent burns, always begin any work with a cool engine. If you're working underneath the vehicle, support it with jack stands and always wear eye protection. And one of the most important but often overlooked items to keep in your garage is one of these, a fire extinguisher, because you never know when you'll need to use it. Now, throughout the tape are several additional safety tips and precautions. Please pay special attention to them because they're for your protection. And lastly, before we get started, you might want to pick up an automotive service manual for specifications and details on your vehicle. Now, let's get started with the tune-up.
In this chapter, we'll discuss the tools that you'll need to do your own tune-up.
Today's vehicles are built to deliver peak performance and economy for a long time. Although it's common for different parts of the engine to wear out, to require replacement and adjustment to maintain the peak performance that you expect from it. That's what a tune-up is all about, replacing and readjusting some of the components inside the engine compartment. Now, no matter what type of vehicle you drive, whether it's an import car or an American car, a mini truck or a full-size truck, and whether your vehicle is older or maybe it's new, many of the tune-up procedures on all of these vehicles are really the same. The procedures that we're going to discuss today are what I would call a minor tune-up. They include gapping and replacing the spark plugs, replacing the spark plug wires, inspecting and replacing the distributor cap and rotor, and if your vehicle is equipped with standard ignition instead of electronic ignition, we'll replace and adjust the ignition points and condenser. And then with the aid of a timing light, we'll check and adjust the ignition timing back to manufacturer's specifications. Now, before we get started, I'd like to quickly highlight some of the tools you'll need to do a minor tune-up. I suggest having a set of Phillips and regular screwdrivers, a set of combination wrenches, either metric or American depending on your vehicle, a set of metric or American sockets, a ratchet and a couple of extensions, a swivel and a spark plug socket, either 5/8 or 13/16, a spark plug or flat type feeler gauge, and the last two items you'll need are a timing light and a tact well meter. These will be used to help you make the precise final adjustments during the tune-up. Now, the first and most basic step of a tune-up is to replace the spark plugs. The spark plugs are a small part of your engine. They play a vital role in overall engine performance. On most cars, spark plugs are usually pretty easy to remove and replace. Of course, some vehicles are going to be a little more difficult than others, but in most cases, they're all pretty easy. Let's look at a typical spark plug replacement.
In this chapter, we'll demonstrate how to change your own spark plugs. Spark plugs, one of the smallest parts of your vehicle's engine, yet they perform one of the toughest and most vital functions in the operation of your engine. Spark plugs must survive temperatures that can range from 500 degrees up to 1600 degrees Fahrenheit. They must also seal the extremes of combustion pressures, battle against oil fouling, ignite incorrect air and fuel mixtures, and survive in the presence of knock and detonation. They work long and hard. On the average, in just 10,000 miles, Up to a 40,000 volt spark will jump the electrode gap as many as 1.2 million times. In addition, the spark plug is expected to perform equally the same throughout its entire service life. To ensure peak performance from your engine, we recommend inspection and a replacement of your spark plugs at least once a year. Worn out, fouled, or deteriorated spark plugs can cause difficult starting, poor performance, poor fuel economy, and even failure of expensive ignition components. As spark plugs age, they require more voltage from the ignition coil to jump the gap. At some point, the spark plug may deteriorate badly enough that there's no spark at all. Although spark plug replacement is one of the most common tune-up procedures performed on an engine, there are still some specific recommendations to follow to ensure a professional job. Always start the work on a cold engine. This will help prevent burning your hands or arms in the exhaust manifolds, which are usually located close to the spark plugs. First, disconnect the spark plug wire by firmly grasping the plug cable boot and remove it with a steady rotating pull. To ease the removal of stubborn spark plug wires, we recommend using a spark plug wire puller. Only remove one plug wire and one spark plug at a time to avoid accidentally mixing up the plug wires. With the socket wrench or plug socket, loosen the spark plug 1 or 2 turns. Next, with a small piece of hose, blow out any dirt or pebbles that may have collected around the spark plug port. This will prevent any debris from entering the cylinder during plug replacement. With the spark plug socket, finish removing the spark plug. Be sure to use a socket designed for spark plugs, as spark plug sockets are especially designed with a rubber insert to hold the plug in the socket during removal. If any of the old spark plugs turn hard all the way out, inspect the threads in the engine for damage or carbon buildup. If any is noticed, run a thread chaser through the threads before installing the new spark plugs. The condition of the spark plugs removed may indicate that additional engine service beyond just spark plug replacement is necessary. Now, prepare the new spark plugs for installation. Always check the electrode gap of the new spark plugs and adjust them to the correct specification.
Gapping your new spark plugs is easy. I recommend using a round wire type of gauge like this one here to gap your spark plugs with. But a flat gauge can also be used if that's the style that you own. The spark plug gaps vary from vehicle to vehicle. I've seen plug gaps range from as low as about 20 thousandths of an inch all the way up to 80 thousandths of an inch. Now, the correct plug gap for your vehicle can usually be found in several different places. It can be found in your owner's manual, the service manual, or many times it's printed right on the emission control decal located under the hood of your car or somewhere in the engine compartment. In our case, the specification called for a gap of 44 thousandths. So I'll just take the 44 thousandths blade of the feeler gauge and slide it in between the positive and negative electrode on the spark plug. If both sides of the feeler gauge contact both electrodes with a little drag, that's right about where you want them. This one feels good. Now, many plugs come pre-gapped from the factory, but it's still a good practice to check them. If the gap is too tight, you can open it up slightly with the other side of the feeler gauge, the built-in adjuster right here, like so. Then recheck the gap. If the gap is too loose, you might want to lightly tap the center electrode on either the workbench or with the gapper itself. A light tap is enough, so be careful. Then I'll recheck the spark plug. Looks like we're okay. Now, once I've gapped all my spark plugs, I like to put a small dab of anti-seize compound right on the threads of the spark plug. This will prevent them from seizing in the threads and make them come out a little bit easier the next time. Make sure you don't get it on the electrodes. Now, this is especially important on many of the newer vehicles with aluminum cylinder heads, where seizing is a much more common occurrence. And one last point, be careful not to bang or drop the spark plugs. You could mistakenly change the gap. Okay, let's take a look at how to install the new spark plugs in the engine.
Install the new spark plugs finger tight. To prevent cross-threading, never start the plug in the threads with the socket wrench. If the spark plugs are located in a difficult position to install, a short piece of rubber hose over the insulator will ease installation. There are 2 different styles of spark plug seats, tapered seat and a gasket type seat. They each require their own method of final tightening. On plugs with a tapered seat, tighten the spark plug 1/16 of a turn past finger tight with a socket wrench. On plugs with a gasket type seat, tighten them 1/4 turn past finger tight with the same socket wrench. Do not over tighten spark plugs, as this could cause damage to the cylinder head or make it much more difficult to remove them the next time. Place a dab of dielectric grease on the inside of the spark plug wire boot and reconnect each wire after changing each plug. This will enable easier removal of the spark plug wires the next time. Make sure the cable is fully seated on the spark plug and clear of any obstructions or exhaust manifolds. Your spark plug installation is finished.
In this chapter, we'll demonstrate how to replace your spark plug wires.
From time to time, you'll need to replace your spark plug wires. I suggest buying a good quality set of spark plug wires. They're already terminated on both ends and are cut to the proper length for your vehicle. Now, due to the high voltages put out by today's ignition systems and the increased temperatures under the hood, it's not unusual for a set of factory spark plug wires to deteriorate in less than 20,000 miles. Now, if you notice any exterior imperfections on the wires, like cracks, bubbles, or burn spots, it's definitely time for replacement. A faulty spark plug wire won't let the voltage get to the spark plug to fire the air-fuel mixture in the cylinders. This can result in poor performance, economy, and increased vehicle emissions. The spark plug wires can break down without showing external imperfections. But without an ohm meter or the use of an oscilloscope, it's often tough to tell if a wire is performing right or not. I suggest replacing your spark plug wires every 2 years or every 25,000 miles. This will help assure good performance and quick starts from your ignition system. On an earlier episode, we demonstrated how easy it is to replace your spark plug wires. Let's take a look at that now.
First, I suggest you lay your new wire set out on the floor or the workbench. This will help you match your old ones up to the new ones so you get the right length wire in the right spot. On most cars, you'll notice one wire that's quite short and a little different from all the rest. That's the coil wire. Set that one aside for now. I like to install it last. And one last point before starting. Make sure you always start with a cool engine. You don't want to burn your hands on the hot exhaust manifolds. Then, begin by removing any one wire from the distributor cap. Grasp the wire as close to the cap as possible and remove it with a steady rotating pull. I like to start with the shortest wire first. On many GM vehicles with V8 or V6 engines, you'll have to remove the retaining ring from the distributor cap before removing the wires. Simply unsnap the latches on each side of the retaining ring and then remove the entire ring and wires from the top of the cap. Then, remove the wire from the retaining ring. On these vehicles, there will not be a coil wire because the coil is mounted right in the distributor cap. Then, continue following the wire on its way to the spark plug, noting its routed path. Remove it from any clips or retaining brackets on the way. When you get to the spark plug, grasp the boot firmly as near the spark plug as possible and remove it with a steady rotating pull. Whichever wire you decide to replace first, make sure you only remove one of them at a time. That way you'll get the right wire back in the right place when reinstalling the new ones. Match the old wire up to the new one to make sure you have the right length. Before installing the new wires, I suggest putting a small dab of dielectric tune-up grease in each boot end. This will help prevent the boot from seizing onto the insulator of the spark plug or the distributor cap, and it can sure make spark plug or wire replacement a lot easier the next time. Then, install the distributor end of the wire back onto the terminal of the distributor cap and push it firmly in place. It'll usually snap when down in place. Then, continue routing the wire back in the same routing path as the original one and attach it to any mounting brackets or clamps along the way. Make sure you keep it clear of the exhaust manifolds though. Lastly, push the spark plug wire end onto the spark plug and snap it into place. There we go. Continue this same procedure with the rest of the wires and the coil wire until you have them all installed.
This chapter demonstrates how to replace your ignition points and condenser.
If your vehicle is an older vehicle or an import vehicle, it might be equipped with a point type of ignition system. Now this system will sometimes require the replacement or adjustment of the points and condenser. Here, I have a point type distributor out of the car. The ignition points are located inside the distributor, underneath the distributor cap and rotor. Here, I'll show you. I'll just unsnap the clips on the distributor cap, remove that, and then pull the rotor off from the shaft. Here's the ignition points and the condenser. Now sometimes the ignition points are called breaker points or contact points, but they all actually refer to the same thing. The ignition points ride on a small cam inside the distributor, and as the engine runs, the cam in the distributor turns and opens and closes the point contacts. When the points are closed, voltage passes through the contacts and goes through this wire to the ignition coil, where it's converted to the high voltage used to jump the gap and create the spark at the spark plug. This energy is then released by the coil when the point contacts reopen. Now, as time goes on, these contacts wear and become out of adjustment. When this happens, the spark at the spark plug, as well as the ignition timing, is both affected and overall vehicle performance suffers. So to keep optimum performance and economy from your vehicle, periodic replacement and adjustment is necessary. One quick note before starting though. I suggest using a magnetic screwdriver to remove the small screws inside the distributor. That'll help prevent accidentally dropping them during the point replacement. Now, replacing your ignition points is really quite easy. It can be done with the distributor right in the vehicle. Here's how. To access the ignition points, you'll have to locate and remove the distributor cap and rotor. With the cap and rotor removed, disconnect the wires that are connected to the point set. You may need to loosen the small nut to do so. Then remove the small screw or screws holding the points inside the distributor. This is where the magnetic screwdriver comes in handy. Then remove the points themselves. Once the points are removed, you can remove the screw holding the condenser and remove it from the distributor. Now install the new condenser in the distributor and make sure to tighten the hold down screw securely. Put a light coat of cam lubricant on the distributor cam. This special lubricant sometimes comes right with the tune-up kit or can be purchased separately in a small tube as shown. Position the new points in place and start the hold down screw, but make sure to start them straight to prevent cross-threading. Just snug it up slightly for now because you'll still have to adjust the dwell or point gap. Next, turn the cam inside the distributor until the rubbing block of the points rests against one of the high points of the cam itself. This is the position where the points will be adjusted at. You may need to crank the engine over slightly with the key, or you may be able to slightly move the cam by hand as shown to line it up. There are two methods for setting your ignition points. You can set the gap with a blade type feeler gauge, or you can set the point dwell with a tach dwell meter. The most accurate method is by setting the dwell, but we suggest using both in combination with each other. First, set the points with the feeler gauge. With the rubbing block of the points against the highest part of the cam lobe, gently slide the feeler gauge in between the point contacts. Make sure the blade of the feeler gauge is clean. Adjust the position of the points with the screwdriver until a slight drag is felt on the feeler gauge and lock down the retaining screw. On some GM and AMC vehicles, this adjustment can be made by turning an adjustment screw with a small hex wrench. A common point gap specification is usually between 16 and 19 thousandths of an inch, but consult an automotive service manual for the correct specification on your car. Reconnect the wires to the points and secure them in place and make sure they are routed off to the side and out of the way of the distributor.
In this chapter, we'll demonstrate how to adjust your points and use a dwell meter.
As you can see, it really is easy to replace your ignition points. And your car might run fine after setting them with a feeler gauge, but I still suggest checking it with the dwell meter for accuracy. Here's how. Setting the dwell of your point-equipped vehicle requires a couple simple hand tools and a tach dwell meter. Most tach dwell meters have 3 leads, 2 small leads and an inductive lead. To check the dwell, you'll need to use the 2 small leads. Connect the red lead to the negative or distributor side of the ignition coil, and connect the black lead to a good chassis ground. Then set the meter to the dwell or cam angle scale. attach the coil wire to a good chassis ground, and crank the engine. While the engine is cranking, check the reading on the dwell meter. It should be within the given factory specification for your vehicle. It's easiest if you have a friend crank the engine during this. You can also check the dwell with the engine running, but that requires reassembly of the distributor cap and rotor, which may just have to be removed again for final adjustment. However, if you have a GM vehicle with a V8 engine, you can actually adjust the dwell with the distributor cap in place and the engine running by accessing the adjustment screw through a small door on the side of the distributor cap with an Allen wrench. Keeping safety in mind, we suggest only making these adjustments while the engine is not running. If the specification for your vehicle is, let's say, 28 to 32 degrees, and your dwell meter reads high at about 40 degrees, it means the point gap is too narrow and will need to be increased. If your dwell meter reading is low at about 20 degrees, the point gap will have to be decreased to bring it within specification. If your reading is within specification, reinstall the rotor in the distributor cap and you're done.
In this chapter, we'll demonstrate how to inspect and replace your distributor cap and rotor.
In the early 1970s, vehicle manufacturers began introducing their cars with electronic ignition systems. Now that did begin simplifying the tune-up by eliminating the points and condenser common to the standard ignition system. Now a couple of items that's common on both systems are these two right here, the distributor cap and the rotor. Their duty is to distribute the high voltage spark from the coil to the right cylinder at the right time. Now different vehicles have different styles of distributor caps and rotors. Yours will generally look like one of these. Now, let's take a look at inspecting and replacing your distributor cap and rotor. Electronic ignition systems do provide long-term and reliable service, although periodic inspection and maintenance is still required for peak engine performance and economy. All of the components of an electronic ignition system can be easily checked and replaced if necessary. Let's start by inspecting the distributor cap and rotor. Symptoms of cap and rotor deterioration include rough idle, misfiring, engine miss under load or acceleration, hard starting, stalling or poor performance in damp weather conditions, or no start at all. The distributor cap can usually be removed in one of three different methods. Here we loosen the retaining screws to lift off the cap. To remove this style of distributor cap, you must turn the hold-down fasteners counterclockwise 1/4 of a turn. And on this style of cap, simply pop the retaining clips and remove the cap from the distributor. Directly underneath the distributor cap is the rotor. Removal of the rotor is necessary to complete its inspection. On most Ford, Chrysler, AMC, and import vehicles, the rotor can be removed by simply pulling it straight up and off the shaft. On many GM and some Ford vehicles, you may need to loosen two retaining screws to lift the rotor off from the shaft. After removing the distributor cap, turn it over and look for signs of cracking, moisture, arcing such as carbon tracking, discoloration, carbon deposits and erosion of the terminals, and electrical punctures. An electrical puncture is a tiny hole burned in the cap or rotor which allows leakage of electrical energy. A gray or brown powder-like deposit on the cap or rotor is usually a sign that an electrical puncture has occurred. If you find any of these problems, or you have more than 20,000 miles on these components, replace them. If you own a General Motors vehicle, a critical area to inspect on the rotor is directly below the center electrode. Using your finger, lightly lift up on the center electrode and inspect it for an electrical puncture or carbon tracking. You may be able to identify an electrical puncture by turning the rotor over and examining the bottom side. Carbon flash and gray-like deposits, if found, are indications that the spark generated by the coil has punctured through the rotor. Often this can be caused by bad spark plugs or possibly high resistance in the spark plug wires. If so, we suggest replacing these parts at the same time. Before installing your new cap and rotor, match them up with your old components to be sure you have the correct replacement. Reinstall the new rotor. Distributor rotors are designed to fit on the distributor shaft in only one direction, but make sure to push it firmly in place. Then install the new distributor cap. When changing the spark plug wires from the old cap to the new one, make sure to only transfer one wire at a time to avoid mixing up the firing order. Once complete, we also suggest checking the ignition timing with a timing light to be sure no change has occurred. These simple checks should be performed at least once every year to ensure optimum engine performance.
In this chapter, we'll demonstrate how to adjust the ignition timing through the use of a timing light.
The ignition timing is a precise moment that spark at the spark plug ignites the fuel and air mixture in the cylinders. Now, the specification for your car can be found in your owner's manual, an automotive service manual, or in most cases, it'll be designated right on the emission control decal located somewhere underneath the hood of your car. This decal will also list a specific RPM for which the ignition timing is to be adjusted at. Now, the ignition timing will usually be specified with the letters BTDC or BTC next to it. BTC simply stands for before top dead center. Some vehicles may have a specification with ATDC next to it, which simply stands for after top dead center. If you have a late model computer-controlled vehicle, you may not find a timing specification or idle speed on the emission control decal. If that's the case with your car, it's preset from the factory and is then controlled by the computer from that point forward. Now, most engines have what is called a timing mark on the pulley or balancer on the lower front part of the engine. Generally, these engines will also have a timing index scale on the front part of the engine mounted to the timing cover. If you can't see it from the top side of the engine, you may have to go underneath the vehicle to locate it. On many front-wheel drive vehicles, timing mark and index may be located at the rear of the engine, and you may need to remove a plug to see the timing mark itself. I've already found ours, and I marked it with a small piece of chalk so we could see it a little bit better when we set the ignition timing. But before we set it, there's usually a small step that has to be made, like removing a vacuum line or disconnecting an electrical connection near the distributor. Generally, though, this step will be outlined right on the emission control decal. On ours, we had to disconnect and plug the hose going to the EGR valve. We had to disconnect and plug the large hose going to the purge canister. And we also had to disconnect a 4-prong wire near the distributor. And lastly, most engines must be fully warmed up and idling at curb idle. Next, we'll connect the timing light. Now, most timing lights are equipped with 3 leads. Black lead, which is connected to the negative post of the battery or good chassis ground. A red lead, which connects to the positive post of the battery. And the third lead, like this here, that's connected to the number 1 spark plug wire. If you're going to purchase a timing light, make sure you get one with an inductive pickup, like this here. Inductive pickup simply clamps over the number 1 spark plug wire quickly and easily. Now, whenever connecting the leads of a timing light or any other gauge, make sure to keep the wires clear of the fan and fan belts, and especially keep them clear of the exhaust manifolds. That's why I like to put the inductive pickup up here near the distributor instead of down by the spark plug. And lastly, we'll have to loosen the bolt a little bit at the base of the distributor. I'm using a socket wrench and a swivel to loosen the bolt up with. Okay, that should be just enough so I can move the distributor by hand. Okay, we're ready to set the timing. But before you start the engine, make sure the transmission is in park or neutral and the parking brake is set. If the parking brake doesn't work, make sure you block the tires both in front and rear. I'll start the engine. Okay. Now, by pulling the trigger on the timing light, I activate the xenon bulb inside the timing light, which flashes once for every time the number 1 cylinder fires. When I aim the timing light at the front pulley, I can see the mark on the front pulley isn't quite in alignment with the mark on our timing index. As I reach over and move the distributor to change the position of the mark on the position of our pulley, you can also hear the engine RPMs going up and down a little bit. I'll align ours with the mark, which happens to be 10 degrees. That's the specification for our vehicle. Okay, I'll shut off the engine. With the engine shut off, and without disturbing the position of the distributor, we'll tighten the hold-down bolt. Okay, looks good. Once it's tight, it's always a good idea to restart the engine and double check the timing to make sure the distributor position didn't change during tightening. Doing your own automotive repairs really isn't that difficult if you take your time, follow our advice, and use the assistance of an automotive repair manual. Now, the procedures we demonstrated during this tape are general in nature and are only to be used as guidelines for performing the same tasks on your own vehicle. Before you tackle your next repair, check to see if there's a Car Care seminar tape available to help you along. I'm Scott Cusey. Thanks for choosing our tape, and I hope you choose us to help you do it right every time. See you then. If you have any comments, suggestions, or topics you'd like to see covered, please drop us a line at Car Care Seminar, 5520 North Highway 169, New Hope, Minnesota, 55428.